Hi everybody. Like Wayne said, my name is Andrew Rush. I'm president of Made in Space. Some of you, know a lot about us. Some of you know a little bit about us, and some of you don't have any idea who we are, and that's okay too. So just to have everybody on the kind of same page, I'll kind of give you a brief background about Made in Space and where we come from, and then get into sort of where we're going. So we were founded in 2010. A group of the founders came out of Singularity University, which is based in the NASA Ames Research Park, and all kind of met up with each other and said, we really have this passion about, helping people, live and work in space. We want to make an impact on people, living and working in space. And after they talked for a long time, what that kind of crystallized around was we want to help make colonization a reality. Like make technologies that help people live in low Earth orbit, in space, as well as on, ultimately on other celestial bodies. And this remains the vision today, to colonize the final frontier, which is kind of a cool thing to say. Interestingly, there are other companies that have these sort of similarity of vision, right? Like a lot of launch providers like SpaceX, for example, say, they want to help conquer the final frontier. They want to make life multiplanetary, because we all see that space is the new Wild West. It's the final frontiers. Because there's more than one, right? There's low Earth orbit, there's the moon, and there's outward from there. And in the truest sort of pioneer sense, we sort of view these companies like these launch providers as building the covered wagons that will take you to the stars. The Tycoon wagon that's reliable and rugged, and you fill it up with stuff, and it takes you where you want to go. Well, the other piece of that is having the tools. Pioneers took pickaxes and wheelbarrows and denim jeans with them to go and go out west and prospect and make a new life for themselves, and that's where we come in. We're focused on building the tools that will help people live and work and reap the benefits of space. The first tool that we kind of hit upon was a 3D printer, and sometimes we get the question like, well, why do you care about that? Well, a 3D printer is really like a meta tool. It's a tool that makes other tools. There are 3D printers that are like self-repairing, which has all these really cool like Terminator 2 visions associated with it. But it can also make things that are adaptable and adapted to your situation. Like if you have a need, if you have some problem, that you have some issue, then you can design up a fix and create it with the 3D printer in a way that duct tape and elbow grease can get close to, but doesn't really fill that void completely. So, the first step in this journey of, opening up the era of in-space manufacturing is, like I said, is that 3D printer. And what we ended up doing was initially demonstrating like very basic idea that, you can do 3D printing in a gravity independent environment. And that was done on just parabolic flights, on the sort of vomit comets, right? And we were lucky enough after doing that to be able to team with NASA and team with Marshall Space Flight Center, as well as work with many other people within NASA to take that that technology, that sort of raw thing, and turn it into real pieces of flight hardware. And so maybe like the biggest thing since the last ISPCS was we successfully demonstrated, we flew on SpaceX 4, in teaming with NASA and deployed our first technology demonstration printer. It's called 3D Print, and successfully printed. We manufactured the very first product, the very first objects off the face of the Earth. Another thing that's really cool to say. And from there, we're proud to say that we've completed building and testing and validating a second printer that we call the Additive Manufacturing Facility, or AMF. And that machine's going to go up soon, and it's going to be a lot more full-featured. The first machine was very much a tech demo. It lived inside the microgravity glove box, microgravity science glove box, and was a really amazing piece of tech. This one is going to live in an express rack. It's going to be able to print in our legacy materials as well as aerospace grade polymer composites like PEIPC. It can also do flexible materials, and it's designed to be upgradable. So in the future, if we want to fly different materials or even low temperature metals, this machine will be able to be upgraded and do that. Because we're really committed to having this be having this technology be a far and wide, shift in how, humans interact with space. Like, right, we've always had this sort of traditional, sort of camping trip idea, right? You load everything up on a rocket and you go and you do things and then you come back. And by having in-space manufacturing, you can begin to change that and begin to, say, well, we're going to go and then we're going to make things and we're going to respond to things and maybe bring some of those things back. We've heard about some really cool technologies, some processes that microgravity facilitates, and that's a part of this as well. One of the things that is kind of emerging out of this capability, this new machine, is it's kind of one of the very first applications of it that we've kind of gotten some legs under is the ability to do actual like assembly and deployment, like manufacturing, assembly, deployment of like small satellites. And we think this is really cool, and there are really kind of four pieces that you need for doing this. The first one is an on-orbit manufacturing capability, and that capability really needs to be able to use materials that are aerospace grade that will survive in the space environment, are high, have good radiation resistance, no low off-gassing, those sorts of things. The second thing you need is a cache of components. 3D printing is amazing, and it's a little heretical in parts of the industries that we talk to, but it is not the only way to make things. I can't 3D print, an iPhone. It'd be cool if I could, but I can't. So, stashing components, the functional components of a satellite on orbit, like the electronics, the batteries, the sensors, and having those available is also key. Third, you need to be able to remotely program things, so that when somebody says, "Hey, I need the electronics board to have XYZ instructions in it," you need the ability to upload that. The fourth piece is an assembly and deployment mechanism. Pretty straightforward. And one of the things that we've announced, and I'm happy to keep talking about it because it's really cool, is a relationship with NanoRacks, which is another, we all know who NanoRacks is. They're a very active participant on the International Space Station from the commercial perspective. So we've announced this initiative called Stash and Deploy, which is essentially trying to take the very first steps in this and say, because between the two of us, we cover all four of these areas. We, with our additive manufacturing facility, have the on-orbit manufacturing capability, and between the two of us, we have the ability to cache components on station, remotely program those things, and then facilitate the on-orbit assembly and deployment of those things. And these are just, and so a question is kind of like, why is this interesting? Well, there are really two big reasons of, at the top and then a whole interesting list below them. But the first reason is getting away from the design constraints of launch. That the launch environment is a very high G, very high, high shock, extreme vibration environment, and designing a satellite for that environment is not actually designing a satellite for the environment it operates in for most of its operational life. It operates in space, which is a lot nicer than maybe the launch environment. So getting away from that is really allows you to do a lot more interesting things. And the second thing is being able to deploy more quickly. As we expand that, as launch capabilities expand on the ground, that may become less of an issue. But right now, being able to deploy things quickly is very valuable to a lot of different customers. So these are just a few of the things that we at Made in Space have done and will continue to do to kind of push this boundary of doing in-space manufacturing and using space for sort of the unique properties that it enables. And I'm really excited about what we're doing. I'm also extremely excited about the other things that other people are doing, because this is something that has to be more than just one or two companies in order to really realize the benefit and ultimately those sort of sci-fi dreams that have motivated a lot of us to be in this room. So thank you.